All right, good afternoon, everyone. Thanks for attending this session. I'm sure a few more people will trickle in, but for the sake of time, I'm going to go ahead and get it started. So today I'm going to moderate this panel, and the title is Laboratory and Analysis Methods for Biochar. I have with me three experts, and everyone is going to introduce themselves and give a little bit of background of how we got here, who we are, and how we can contribute. And that's probably going to be around half an hour, hopefully, to go through the four of us. And then at the end, I'm going to leave a teaser slide with some suggested topics. But I want at that time to open it up to all of you to just bring in your questions, comments, suggestions on the topic. All right, thank you. So my name is Isabel Lima. I'm a research chemist with USDA ARS, Southern Regional Research Center in New Orleans, Louisiana. And I'm actually missing my first Mardi Gras for a while. It's today, and I'm here instead, but it's okay. This is our building. Come visit when you want. It's lovely over there. A little bit of background. I have a master's and Ph.D. in biological and agriculture engineering in UC Davis, right in our backyard here. And then I got a postdoc at the USDA for a few years. And then in 2001, I got a position as a research chemist. And that's when my biochar work started. That was in 2001. At the time, the word biochar was not even defined. It was, I called it pyrolytic products. I started with an activated biochar, and my project at the time involved using biochars, or at the time activated carbons, to solve an animal manure problem. So basically, we were trying to address that problem with the agriculture community as a whole. They had huge problems with combined animal feeding operations, animal manures, and we started, my predecessor at the time was doing some research on activated carbons, so we started by converting those wastes into activated biochars. And that went along for more than a decade, and most recently in the last decade, I've transitioned a little bit to do the same thing, but my feedstock of choice now is the feedstocks from the sugar crops processing, and they can be sugarcane bagasse, can be sugar beet pulp, and sweet sorghum bagasse, and even leaf residue. And I've transitioned a little bit more to using the biochars as a remediating agent material to absorb heavy metals, to using these materials for soil amending applications. So it was transition both on the side of the feedstock and the application. Through the years, I've had the opportunity of producing hundreds, if not thousands, of samples of biochar. I have a little biochar show and tell in my pilot plant, and I have biochars that I made 20 years ago, 10 years ago, 5 years ago. As part of the USBI Board of Directors, I was tasked about 4 years ago, right around when the pandemic started, to look into doing a survey of the existing laboratory facilities in the US and abroad that determined the biochar testing capabilities. And there was, I gotta say, it was a little bit of a frustrating process because I guess because due to COVID, a lot of the laboratory facilities were doing remote work, and you can't really do remote work when you're analyzing samples. So I had a really hard time identifying laboratories that would even do the bare minimum in terms of what's defined now as an IBI standard. So I've contacted lots of them. I had very difficulty getting a hold of a lot of them, and the ones that I did get a hold of them, things changed over time. They were doing certain tests, and then 6 months later to a year later, they were no longer doing those tests. And in this process of surveying the existing laboratories that would do this type of work, there was a little bit of education process because a lot of these laboratory facilities had no idea what biochar was. So I had to educate them what it was and the tests that we would want them to be doing. So there was an interesting process that kind of brought me more understanding the issues. So now delving into furthermore, what's the challenge then? Biochar, as you know, is made from a wide spectrum of materials, and those materials have wide properties. You can go all the way from the woody byproducts to the refinery plant wastes, all the way to the manures, right? They have very high ash content. So you have a slew of materials and so many materials, and that makes things challenging. In addition to that, you also have a broad number of end uses for biochar, and that number is increasing. We just more recently heard of biochar being used in cement, right, in asphalt. So those are things that 10 years ago nobody heard about. So that makes things even more challenging. Not only we have different feedstocks, we have different ways of making biochar. You can make it in a batch mode. You can make it continuously. You can change the residence time. You can change pyrolysis temperature. You can change pre and post treatment to your feedstock to impart certain characteristics on your biochar. So all that produces hundreds, if not thousands, of different biochars with different characteristics. Then you have the fact that biochars, just by holding them, might change their properties over time. So all this makes biochar a very, very challenging material to have standards for testing. So ideally, we want to do biochar characterization and match it to the final utilization. So if we want to use a biochar for soil amending, we probably need only a certain set of characteristics for that biochar. But if you're using it for remediation, then that set of characteristics might be totally different, and some might be common. So we have good news and bad news. The good news is there's a large number of applications, like I said, potential feedstocks and pyrolysis conditions, but this means there's a large number of potential markets for biochar. That's great. That's why we keep hearing about biochar being used in the most incredible of ways. But the bad news is exactly the same thing. Because we have a large number of applications, potential feedstocks, and pyrolysis conditions, that means that we have challenges in characterizing all those materials and understanding what needs to be done. So we also have new uses, as I mentioned, and better testing will always come. There's always going to be refinement in testings that are probably cheaper, that are more accurate. So, and the testing has to be kept up with all these new uses of the biochar. So that also presents a challenge when developing these standards. So biochar standards. So in principle, we want to define, analyze, and communicate the essential characteristics that define each biochar that we produce. So we need to identify the physical, chemical properties to be tested of that biochar. We need to determine what tests can measure those same properties. We need to define acceptable thresholds for some parameters. Example is the toxic, right? Heavy metals, for example, PFAS, etc. These standards then become the common framework for biochar analysis and testing. And the materials can be compared for the benefit of the biochar's users, marketers, producers, etc., because they can compare biochar side by side in terms of their properties and decide this works for me and this maybe doesn't work for me. So ideally, those tests and standards are affordable and accessible. And ultimately, the biochar industry can benefit from a certification process if that's the way to go. That is based on the established standards. So at this point, I move on for Chris, and I'll let him introduce himself.
Thank you. Oops. Hello, I'm Chris Weiberg with Timber Products Inspection and Biomass Energy Lab. We have a facility in Conyers, Georgia. That's a suburb of Atlanta. So this is a picture of our facility. If anybody has the opportunity to visit the area and would really like to come see our laboratory, we actually have a pretty open house policy for people coming to see it. We're proud of it. And David Robles down there is the gentleman that runs it daily for us. So basically reach out if you want to come check out our laboratory. A little bit about the company. So Timber Products Inspection, as the name implies, is essentially what we are is, we're a certification body, inspection body, testing body for the wood products industry. Some examples of these products, the lumber industry, treated lumber, wood pallets, packaging materials, trusses, 2x4s, utility poles, wood pellets. Basically, if it comes down to a building material or product that has some kind of a grade behind it that requires confirmation of conformance, our team of people are out there inspecting these products to make sure they're in conformance. We have an army out there. We have about 70 inspectors in North America. We have others internationally. And essentially their job daily is to just go to manufacturing sites, inspect the plants, and make sure that they're actually manufacturing in accordance with whichever industry standard they're trying to achieve. This is supported by 3 laboratories. All in that original picture I showed you, we have a physical products testing laboratory. This is essentially like structural strength of lumber, engineered wood products. We have a chemical laboratory, which is more for the treatments, so pressure-treated lumber, wood preservation, that kind of thing. And our laboratory that we operate is the Biomass Laboratory. So we operate essentially as a solid biofuels laboratory, and of course, part of that is the thermal treatments of solid biofuel, which lend themselves to biochars, biocarbon, biocoal. We actually are involved in quite a large number of standardization efforts, and this is throughout the company. I think we counted about 24 different working groups, ASTM committees, different industry standards. So we don't just enforce the standards that are provided by various industries. We're on those committees. We're very active in standards development. The corporate headquarters is in Peachtree City, so the southern part of Atlanta. The laboratory itself, so we're ISO 17025 accredited, and we like to stick with that. It really becomes difficult for us when we can't accredit to methods, and this is because of just it's the third-party turnaround of routine ongoing production. Laboratories tend to focus on their core, do it very well, and then accredit to the core. We do ISO, we do CEN, EN, and ASTM, and essentially all of the solid biofuel method standards. I've got a list here of different things. Probably the biggest thing we do is wood pellets. So we're the U.S. domestic wood pellet industry through the Pellet Fuels Institute. We're also very involved in export markets, so the loading of ships of wood pellets. But we do wood chips. We do all kinds of agricultural and pits, seeds, nuts, shells, coconut hulls. If it's a form of biomass that somebody wants to try and turn into an energy product, we've probably seen it in our laboratory. And this includes all the thermal applications of that, whether it's torrefaction, steam explosion, biochar, hydrothermal carbonization, biocarbon, and biocoal. Of course, these are all similar products, but different applications. And we do certifications of some of these products. Some examples for the wood pellet industry here in the United States. The Pellet Fuel Institute standards are essentially the residential domestic process. We're a certification body, inspection body, and testing body for that certification scheme. And then internationally, EN Plus is another wood pellet certification scheme. We act as an inspection body and as a testing laboratory. So a little bit about my personal background. So I've been in the biomass lab since '98. And I'm not sure how many years that is, but bottom line, I started in a coal lab like so many other people in our industry. And biomass was there, we just did it the coal way. And at some point in time, people started asking questions. Well, how do you test our biomass? And the answer was a little embarrassing. Well, kind of like I test coal, And, eventually I get asked to go to a conference and provide presentations, and I learned that the industry was at odds with itself. It really didn't have standards. So I challenged the industry back in 2005 to say, look, the solid biofuels industry really needs to have standards. And this is where the Pellet Fuel Institute started standards development. Took about 10 years to put that standard together, but starting in about 2008 or 9, I became the chairman of the PFI Standards Committee, and I've been the chairman of that standard ever since. In 2007, we were informed about all of the CEN and EN standards that were developed through the European Union. They were originally published as CEN and EN standards, but once pervade as European national standards. They wanted these standards to be able to be used by the entire solid biofuels industry. So they forwarded them on to ISO, and they created a new ISO technical committee. It's ISO TC 238. Once opened, all countries now have the ability to participate in these standards. And so the US created a working group. It's been created through the American Society of Agricultural and Biological Engineers. It's called ES 238, and I'm the chairman of that group. So essentially what our laboratory does is we've adopted all of the ISO standards developed for solid biofuels, which includes biochar. The thing is, that solid biofuel designation implies that you're going to burn it. But in this case, you just don't. So the methods that have been developed are essentially everything from sampling and sample preparation through all the different types of testing to specifications and certifications. These are already in place today for solid biofuels and adoptable for biochar and biocarbon and other thermal treatments. So I remain very active in this group. I'm on several working groups 1, 2, 4, 5, 6, and we're about to create an 8th for biochar. Done my share of project leadership, and we've got an active task group called Task Group 1 specifically for a roadmap for biochar. So I'm going to leave that as the teaser for additional discussions. So on to Katie.
Good afternoon, everyone. I'm here representing kind of the academic world. I talk about process impacts on biochar properties. Fear not, I don't have that many slides. A little bit about just background to see where we're coming from and how that impacts standard development. I started in chemistry and then went to Iowa State and worked on chemical engineering and biorenewable resources. My thesis title was Biochar Characterization. And this kind of started, like most theses, by accident. I was working in a research group that designed fast pyrolysis reactors and gasification reactors, and they produced some amount of char, and it sat on a shelf. And I had went to go hear Johannes give one of his talks in 2008 or 2007, and I was so excited, and I asked my advisor, well, we make char, don't we? Can we use it? And he said, well, most people don't think it's any good because it's not made in a kiln. I said, has anyone checked? Well, sort of. And I said, aha, I smell a thesis topic. And so that's what happened is I started looking at what methods were available to answer the question, is this a good thing? Is this a good char from fast pyrolysis and gasifications compared to these biochars that I'm hearing about? And so that's where it started. After that, I went to Rice for a short while to work with Carrie Masiello and Kyriakos Sigarakis on biochar physical properties. And then 11 years ago, I started at New Mexico State University in chemical and materials engineering, where I've been mostly working on biochar's impacts on arid ecosystems. There's been a lot of work in the tropics. There's been a lot of work in temperate climates, not as much on the arid agroecosystem side. And so we're kind of going back to square one of, is biochar good here? If so, under what circumstances? And some of that has also been development of value-added products. And so I've been in and out of the biochar world back and forth depending on the projects, but this is where I like to come back to answer the questions of, is this good? And if so, good for what? So there we go. My students absolutely hate this answer that I give them. They say, is that a good thing? And I'll say, well, the engineering answer to everything, it depends. So application, as Isabel said, determines the desired biochar properties. The desired biochar properties determine the property measurement requirements. The property measurements and feedstock availability determine process design, and then process design determines co-products and economic feasibility. And so the part that I'm most interested in is that part in the middle. Our feedstocks come in at a certain condition, and we need to know what should we do with them. And we're trying to get some kind of target. But that middle part is really tricky because all of those characteristics and every single time you change a process depend on what comes out. And so for all of you, as you have conversations later on in the conference, if you remember nothing else from my talk in the session, if someone says, is it good? What do you say? It depends, okay? Biochar can be a wonderful thing and it could be a not so wonderful thing, but make sure you can answer the questions of it depends on what. All right, so with that, I'm gonna hand it off to Lalitha.
Hi, everyone. So I'm Lalitha. I'm here representing Celignis Biomass Lab. I'm here with my colleague, Daniel Hayes, and also the founder of Celignis, all the way from Ireland, West Coast. So we are a biomass lab based in Ireland, but we are more than a lab because we do bioprocess development there, and we have a whole bunch of process engineers, biochemists, biotechnologists. So we work more as a research and service provider than just analysis. So I explain how we do that. So, okay, it seems like I wrote a bit too much about myself here. So I'm a biotechnologist, and I got some fellowships here and there. I did my postdoctoral studies in process engineering, which really helped me to understand the importance of process in making the useful product, right? And how we relate feedstock with the product. And from India to South Africa, and then I moved to wonderful Ireland, where I joined Celignis. And Celignis, by the time I joined, it was 5 years old. Now it's 10 years old, slightly more than 10 years. Within this time, I've analyzed more than 20,000 samples. So you name it, the biomass type, the feedstock, we've analyzed it. Right from all kinds of sludges and slurries to the most beautiful red seaweed. We've analyzed it for a variety of molecules, a composition, and so on. We got 1,000 clients globally. And as a process development lab, we've also developed more than 20 different processes, and also Irish Awards winner in 2021. So now, how do we bring this expertise, this group of expertise that we have in Celignis in the space of biochar? The very first is feedstock evaluation. So we help the clients in the project development right from understanding the feedstock, whether that feedstock will be suitable to produce the biochar for the target market, because it's always what market are they targeting, the client is targeting. And we do, we follow EBC and IBI standards for testing the biochar. We're not an accredited lab, but the way we work is we work with the project developers to make sure that the biochar meets the limits that are specified under these standards, and we might look into accreditation in future. And another most important point is because we work in different types of processes, we know process integrations very well. So that means if you are doing an anaerobic digestion project, and we can help in integrating the biochar with the anaerobic digestion or any other bioprocess. So using the residues to produce the biochar and which markets that biochar would be suitable for. And we also have a small lab-scale biochar production testing that helps in screening a variety of feedstock of producing the biochar. And in addition to that, we help in techno-economic analysis and also research collaborations. We are based in Europe. We are very well known for our research collaborations. We are in several EU projects with 13, 14 partners. So we know very well how to work in large consortia of projects. And in that slide, you see a whole lot of different analysis. So we do basic analysis that are given in the EBC and IBI, but we understand the limitations. We know that that doesn't fit all the market needs. So we also do some additional analysis, the advanced analysis that are really needed to sell your biochar or to use the biochar in the suitable market. Yeah. And that's all from me. So yeah, we have a stand. So if you have any questions on on biochar, you can ask us. Yeah.
Thank you. Thanks everyone. So The way I think this is going to be done better is if I open it to the floor. Please let us know if you have any questions. I'll bring the microphone and we can see who can answer them better. Yes, Hugh. Okay.
If you have alpha particles, I have a lot of concerns. Ours is pretty typical because for moisture, we expect it to vary during storage, what part of the bag it came from. And so we tend to keep our moisture very simple. You start with 2 hours at 105 in a furnace. You take it out, cool it in a desiccator, weigh it, put it back in for another hour at 105, take it out, cool it in a desiccator, reweigh it. If it hasn't changed or changed within a certain amount, you're done. For most of our processes, that's the level of precision that we need.
So we follow ISO 18134-1. It's a reference method, not a simplified method. It's 105 degrees, and it specifies to put it into the oven for as long as necessary in order to get out all the moisture, and that's gravimetric. So we put it in generally, if we receive a sample today, we put it in today, we'll pull it out tomorrow morning. We keep them in there overnight. The next morning they are weighed back and then put back into the oven, wait an additional hour, weigh them back a second time, and then verify that there's no additional weight loss or within a tolerance of weight loss. After that, they are weighed back hot, and so there's a buoyancy correction that has to happen. So they're embedded within 18134-1. There is a reference pen that's used to measure the buoyancy, and then that's included in the calculation.
I use ASTM method using my TGA, right? And I just do the protocol. It does a 107 and the nitrogen atmosphere, and it does so until there's no change in weight, and there's a criteria of the weight difference. When that happens, it moves on to the next cycle, which is the volatile. It raises it up to, well, but that's something else. Macro. It's up to about between 0.6 and 1.2 gram, 1.1 gram sample.
Maybe I can, because I mean, if you're measuring so many samples, moisture is something that needs to be corrected for any kind of analysis if we have to report on dry matter basis. And that's the standard method of reporting for any analysis. So yeah, we follow the same protocol as Chris was mentioning. Yes, there is buoyancy correction. We do not necessarily always do overnight. It depends on the type of sample. So we start with 2 hours, and we keep measuring the moisture till it is stable. Of course, the first 2 hours we'll understand how quick the moisture loss is, and then we can always determine how long it would take. Of course, there would be at least 3 different points we take in order to make sure that it's within the correction factor. So it's the same standard method. It's 105 degrees oven, and unless it's inherent moisture, which is a different story. So if for inherent moisture, then that's 40 degrees. So it depends what type of moisture we are looking for as well. So yeah.
And just to follow up with that, may we ask you, what would you suggest of the best way to measure?
I'm going to say the analysis we use depends on the purpose. And if our purpose is the reporting, or in my case, the design of the reactor, that's what we go with. Because we're not using it as an activated carbon here. But yes.
I've got a very different question, and I don't know the answer to it. I'll start with a little story. I teach gardening classes. When I do the soil class, I ask, what is the best plant? And it's the soil that you have. It's the soil that you have, and then we learn about soil textures and composting and nutrients. And so, suppose I have a flame cap kiln, and I put in common forest debris from my area or yard, and make biochar, and I've got a batch. It's the biochar I have. You know, my experience with it is I don't control the temperature that well. I think it gets a little hotter, and it's a flame cap. It's low oxygen. It's not no oxygen. And so it's not going to make it to a laboratory. What advice do you have?
I'm going to try this one first, if that's all right. When we do extension events at our field days, and people ask me, is this a good char? And they said, I saw your paper, it had NMR. I'm like, just stop, don't. You don't want to go there. There's a couple of things that I tell people to look for to know if it's a good char. One is the color. It should be black. It shouldn't be brown, you undercooked it. It shouldn't be white or gray, you overcooked it, over-oxygenated it. It should be black and kind of shiny. Then if you pick it up, it should be pretty easy to crush. I mean, a big piece might be hard, but you should be able to crush it. It should be friable. And it shouldn't leave a greasy feeling on your hand. It'll be dusty, but it'll be dusty, but it should never feel greasy. And then when you smell it, you might smell a tiny amount of barbecue if you get it really, really close. But if you open a box of it and suddenly you're like Texas barbecue pit, you got a problem, okay, with volatiles. And so is it black? Not brown or gray? Does it have a lot of smell? Will it crush? Does it wash off easily? And I would tell people start there. There are so many other methods you could do, but if you need your first eyeball on it, that's where I tell them to start.
I can't say that I have anything to add to yours. Do you have anything?
Not much, only one point, especially what's mentioned there. If you look at the biochar, it should be lighter. It shouldn't be very dense. That's, when you feel it, it should be lighter. So that's another important point to say. Yeah, that's all from me. You've covered almost it. Yeah, so otherwise if it's very dense, it's going to cause compaction. Yeah.
Like to augment Kate's greasy assay. It was actually a test that Tom Reed developed years ago called the soap test. Basically, you take your jar, you rub it on your hand, and then you go over a pail of cold water. You rub it in the cold water. And most of that comes off. That's called passing the soap test. If you need soap to get the black one, that's the grease that came out of the chunks. And you now have defined greasy bias. That is literally called the soap test. It's extremely accurate.
Does that answer your question?
Is the application going to be soil amendment or what was the application?
When I answered that question, it was the question of, there was one more point. I asked them, what did you make it out of? If you're making it out of the treated wood from your kids' playground leftovers, okay, as long as it was clean biomass feedstock going in, I'm not worried. The application, it's going to depend a lot, but what I'm looking for as a chemical engineer is it undercooked, overcooked? And was there the right escaping of volatiles? And that's the question I'm trying to answer is, did I make char? Did I do pyrolysis?
I just want to, for the soil amendment, it really depends, right? Because if you put biochar into the soil, and if it is not charged, and if you put biochar directly, that may have, not going to, but it may have some negative effects if it's coming from, let's say, wood-based biochar, which doesn't have a lot of ash. So it's also important that to see where, let's say, what's the nutrients or minerals content in your biochar, and if you have to charge it, you have to charge it. Otherwise, if you put it into soil, it's going to bind into all the nutrients, and that will reduce the plant growth. So it's important to know the feedstock and how much ash and stuff you have in there. Sometimes ash is good. So yeah.
Thank you, guys. I've got a question. It's probably not specifically biochar, but it's a biochar byproduct. We make a lot of, I call it smoke condensate. Japanese would call it wood vinegar pyroligneous acid. We're looking for a good protocol on testing. If you look at the Japanese standards, what there are, it's not much more than pH, colour. I think they do go to acetic acid, and that's about the limit of it. What should be looking for, and can you give us some recommendations, please? And another thing on testing, Stephen Joseph, a good Australian colleague who does a lot of work in Asia, taste it. If it's clean water that you've been using to quench it, don't be afraid. Taste it. If it tastes clean, no taste, slightly salty, slightly sweet, that's good stuff. If you spit it out, throw it out.
As a former chemist, don't lick the science. But in this case, I guess it's char. So testing of bio-oils, insert other names for them here.
Yeah, we do quite a lot of liquids testing. So the ion chromatography is the best way to test, because you can get, or you can also use GCFID. The main acids that you would get there would be formic acid and acetic acid, that are the degradation products of the sugars. And you also get furans and you get phenolics. So these are the different types of compounds that you normally find there. And you can analyze that. Most of it can be analyzed by GCFID, but if you use ion chromatography, you can speciate all of these, polyphenols, furans, acids. And then if you want to use this product, use this liquid as a product, and if you want to fractionate, you can actually fractionate the organic acids from the phenolics. So in the case if your condensate has phenolics in there. Yeah. Me? Okay. Yeah, sure. Yeah.
Very cool to have you all here to answer these questions. So my question is more on, there are very few of you. There are very few labs that can produce these kind of reports. And if the biochar industry is going to grow, it's going to need more and more and more testing. So, for example, if, let's say, one person is like, okay, I want to open a only biochar facility, only biochar testing facility, because they have a lot of faith in the biochar growth right now. What would be the specific equipment that you think would compass the broader area of biochar testing?
Yeah, well, I can take a go at it. So that's exactly why we're here. Right now we have IBI standards, but they're not really certified, and they were done a while back. And we now understand that there's so many different applications of biochar that we need to cater tests for probably a biochar application. So I think we have to start first to define what we need to determine to be the characteristics of a biochar, and it's going to be a lot of them. And that doesn't mean that a person that is trying to purchase a biochar or manufacture or understand about a biochar They're not going to exhaust all tests of that biochar. Maybe they're just interested in one specific set of tests. But at this moment, there's only one test in the US that does the vast majority of those IBI standard testing procedures, and they're not certified. So we first need to identify what are the sets of analysis that are important to do, what we need to determine, what are the best tests to achieve that, determine what the parameters are for certain things, and then we have to go through the process, just like Chris mentioned, how it happened with the fuel pellets, and how they went through the International Standardization Organization to define something that would be usable, probably worldwide. So that's how we have to start. We have to start that way, and that's a long process. Once that's done, then we have to reach out to laboratories and determine which laboratories are capable of carrying out what tests and letting them know, this is the set of tests that we identified we have to do, and this is how you have to do them, and tell them what the methodologies are exactly, because what's lacking right now in the IBI standards and procedures for biochar testing is that they speak nothing to biochar preparation. You have no idea. Do you have to grind the biochar? What particle size do you use? Different tests probably require different preparations of the sample. So all that needs to be described, and it's a very tedious process, and Chris can probably talk more about it, but I think we need to start that way, and then at the end identify laboratories that can perform those tests and tell them that's exactly how you have to do. You have to follow the guidelines.
So I'm going to go back to the first part of your question, why are there so few laboratories, right? And it's simple. It's, getting handed as a laboratory from our perspective, right? So somebody comes to us and says, here's the IBI standard, can you do this testing? Oof, boy, I tell you, it's a real sigh when I look at it. It's a conglomerate of several different industry standards pulled together for the purpose of classifying biochar, but there are compost methods in there, there are charcoal methods, there's solid waste methods, there's research methods that reference individuals. We're an accredited lab. When we accredit a test, it has to not just be accreditable to that listed method, but the supporting methods that are embedded within it. So like our forte is solid biofuel. So the work product of ISO TC 238, we have around 50 standards, starting with sampling that lead to sample prep, that lead to all of the individual tests that are used, then specifications, and finally we can certify products using that entire suite of everything. The IBI standard does not have that, and you're missing all kinds of parts, and when a laboratory gets that, if I'm brave, I will say, okay, I'm going to give this a shot. And I'm going to come up with something that can deliver to these individual standards. And what I'm going to deliver you is a number. And then Lalitha is going to do the same thing. She's going to get that, and she's going to look into it and try and figure out her way of doing it and come up with her best interpretation. And then she's going to deliver a number. And although our labs might be reputable and even accredited, our numbers might not match, simply because of a difference in how we decided to put it together. In order for this industry to really flourish, it needs to have that alignment of all the different methods. And I'll offer that it already exists, at least for the most part through ISO TC 238. The almost 50 methods that we've already created were designed for solid biofuels. The precursor materials that are already used mostly, except for manures. I don't think we have sludges and manures and biosolids included. But for the larger share of the type of products that are produced, these methods are already largely aligned. They need some subtle tweaking, but we already have a sense of what that is. And we already have a process started to develop them into biochar methods. And I had mentioned earlier that so we have a working group here in the United States. It's called ES 238. I chair that. And essentially what it is under ISO TC 238, there's about 25 countries that actively participate. There's another 25 that are observing members, right? But those 25 active participants, we get together in working groups and wrangle over what all these details are supposed to be and say. The US only gets one vote. And so we have a separate group called ES238 where all the US representatives get together and say, what's our vote? What do you think? What do we think? What's best for the United States? And in the end, we purvey our comments. I chair that initiative for the United States. The good thing about this system is that anyone in this room who would want to participate can just say, hey, Chris, can I get on that group? And the answer is, yeah, you can. We could get you on as a voting member. We could get you on as an observing member. We could even have you involved in an individual working group or task group that's germane to the individual effort. So the system's already in place. What we are waiting on is an adoption of a new working group within this structure and a modification of the scope. So about 2 years ago, Tom Miles, there, he just walks in and I mention his name. So about 2 years ago, Tom approached ASABE, which is where the ES238 group is housed, and said, hey, we really need standards for our biochar. And it began a conversation which led to deeper and deeper discussions within the ISO TC238 group. But we created what we call Task Group 1. It's under Working Group 4, and for the last 2 years, this is globally, about 25 countries participating. We have come to the creation of a roadmap which should be ready in May. What we're hoping that this ISO TC238 will do in May is create the platform for international development of biochar standards. So there's still a little bit of work to be done. Not all is perfectly cast. There's a couple of differences in how people philosophically want to do this. We already have 7 working groups within this effort. And the one idea is, well, we can just divvy up this work between the existing 7 working groups, and therefore we got a large cadre of people already involved and continue that work. The flaw with that is these are generally solid biofuel interest people. Some of them are biochar people. And those of us who are typically on Task Group 1. What we would like to do is create Working Group 8, which is a new initiative to populate it with new experts solely focused on biochar. And then we can take the existing standards, we can review each one and tweak them, and create them into what they need to be for biochar. In addition, this platform can be used for new work item proposals for any sector. If we wanted to create a filtration method, we could. If we wanted to look at soil chemistry methods, we could. And there's no real restriction as to what we might be able to put forward as long as we can populate it with experts. So there could be subgroups within the group. So there's a lot of options. So I offer to anybody who wants to be active to come up to me, come up to David Robles. You know, we're here at the conference, we're at booth 505, and we are recruiting experts for this industry to be the US voice in this initiative. So to your question, thank you. That was a very good question, and I, for one, would love to see this come along a similar track. Patience is a virtue, though. It usually takes about 3 years to develop a standard, and there's a lot of reasons why that is. Because it's global, everybody's got to have time to look at it. And multiple times. It's not just a one and done thing. So I don't know if I left something out on the...
Okay, I've got a different question. Could you discuss what types of properties you'd be looking for in a biochar to address heavy metals in a mining operation or legacy mining? And feel free to talk about feedstock and pyrolysis conditions.
Any guess what I'm going to say? It depends. Very good. It depends on which metal. And something I've also learned working in the biochar field is just when I think I've found the perfect pattern, someone will take a closer look and find that there's more to the pattern that I didn't quite notice. So if you had asked me this question 5 years ago, I would have said, well, you're trying to absorb a metal, and a metal is going to be in water, and it's going to be positively charged, because that's how the metal's going to move. And positive charged things stick to negatively charged things, and therefore I want a biochar that has lots of surface functional groups, which means you're going to cook it at a low temperature and keep all of the carboxyl groups and carbonyl groups and all those other things there. Now I'd say I'm not completely sure. I'm pretty sure I want a lot of surface area, because usually more surface area, more places for stuff to stick. Therefore, I probably want something with some, smaller pores. Smaller pores means more surface area. But there's also how biochar ages in the environment and how quickly it ages and all of those things. And so I've come to the very humbling conclusion that I'm going to have to test it. And that'll depend on which metal, which water is it in. Something we see in New Mexico trying to work with water treatment is we have so much salt in our water, different kinds of salts, and all of those things interfere with absorption. And so it may work perfectly well if I have the DI water and my, cadmium nitrate solution that I made from weighing stuff out. I might get one thing. You put it in a real water, and so there's been some work, but this is something we're currently trying to figure out with uranium. And uranium is special because it has all sorts of oxidation states in water, and those oxidation states will probably stick differently to different chars under different pH conditions, different co-ions, etc. So I'm going to say it depends, and I'm not completely sure what it depends on yet. Others?
I just want to add one more point, or maybe two more. So the hydrophobicity and hydrophilicity of the biochar also plays a very important role in the adsorption. It's because there is electrical conductivity that a lot of the time we don't give enough importance to it. But when it comes to the bioremediation, electrical conductivity plays a very important role because the redox state, the way it switches. And yes, I mean, the surface charge is important to an extent if it's looking for, let's say, the free metals, but not all the cases. And there was some discussion this morning. Actually, it's quite nice. I'm learning a lot being here. So someone came to a stand this morning, and they were asking about the electron surface, holding capabilities of the biochar and how to test that. So there are new ways of analysis coming to especially understand the bioremediation sector, because I think this is one of the least studied, because we are very much used to the adsorption kinetics of, Langmuir and Freundlich models and do that and, get the Ks constants. But if we have to do it in terms of the analysis, which biochar is good, what properties to correlate, we should consider hydrophobicity and electrical conductivity as two other parameters that needs a correlation, other than the surface area and porosity. So
It's just one final note. I've done a lot of remediation studies in the early times, and what I found out is that when, say, you study one single, say, copper, right, 2+, study one single heavy metal, and then do a beautifully prepared laboratory solution at different concentrations, and you put different perfectly measured quantities of biochar, and everything behaves good. Now try to put 2 or 3 other heavy metals, then they start competing for each other, and then you don't understand how they compete, and then you go from a beautifully prepared laboratory solution to a real situation out there where there's all kinds of other things that crowd the water. And that's when the big challenge comes. And the other thing that I've also noticed is that because I traditionally started with activated carbons that were made from coal and from things that are very clean, very high in carbon, all of a sudden you have these biochars they have all these other very interesting impurities, as you could call it, then they don't really behave like an activated carbon. And then you think that porosity is important, yes, surface area is important, but there's all kinds of other things, and you cannot really even measure them the way you measure a traditional activated carbon with just looking at the functionality the way that it's traditionally defined for an activated carbon. So I would say it depends and it's a challenge.
One way that you might study this is get a char in the scenario where you want it to be tested, do a preliminary study. Okay, we put this stuff down, we're measuring the concentration of the water at this leaching point and this leaching point. Get the data and then say, okay, this is what I saw. Now, does it make sense? And then if it makes sense, then design your experiment, because then you'll know what are going to be the competing ions, what other stuff is going to be in the water or in the soil. You're likely going to have to do several iterations to get that good experiment to know what your parameters are, because otherwise you'll spend all this time in the lab setting up a study only to get data. Yes, and I can tell you that transition to the real world is, you're adults, I'll let you fill in the word at the end, but it can be quite challenging after our nice, pretty, clean laboratory samples.
I don't know if anyone's familiar with like RCRA standards or TCLP testing, but kind of in the light of understanding whether a biochar would help remediate or affect, heavy metals leaching into the ground, that could be a possible option to test something out kind of before you're waiting for your soils to go over time. Is that something you can do in the lab?
Anyone want to take that one? Was it? Oh, add-on. Okay.
Hi. Lalitha and I were actually discussing this earlier, but extractable nutrients, they're really difficult to predict for different soils. So I just wanted to know what you all think about the current extractable nutrients methods, the 1 molar HCl for calcium, magnesium, and sulfur, and the 2% formic acid for phosphorus. How real world relevant are these extractions, and are they really any better than just doing a total nutrient analysis?
That makes me nervous when you look at me like that.
I can answer that. Yeah. Rachel and me, we had a good discussion about it previously, because the current methods, IBI standards, they ask using formic acid, which is organic acid, and HCl for different types of nutrients. And now the principle behind this is, under acidic conditions, these nutrients, they come out of the matrix and they're available to the microbes. But in the real world, in soil, it never goes to that pH. It is just not possible. And if at all it goes to that pH, there will be other interactions, carbonates and other, that are going to now form complexes with the released nutrients. And it's bioavailability is a very simplified term, I think, in what we say with biochar, because bioavailability when? Now, in next 7 days, or next month, or this year, or in 15 years, or 50 years. When is it going to be bioavailable? Because these methods are just saying this is the amount of nutrients that can be released under acidic conditions, so that means these are bioavailable. But it doesn't say how easy they can be released, and under natural conditions, you don't get that sort of pH changes in the soil. So modification of that method is really important. That method is based on the compost systems, where it's easy available nutrients and the release is quite faster, where in biochar they're held up very tight, and the release can range from 15 to 50 years. Like for phosphorus, it's a lot longer than potassium. So we need better protocols, certainly for bioavailability of nutrients. And this is very important because yesterday there was an excellent discussion on the nutrient management regime using biochar that is high in nutrients. And if we do not know the bioavailability right, how are we going to estimate how much biochar is needed per hectare? Because we do not know how much is available. So this method certainly needs improvement, and it's very much needed improvement if we want to use it for soil amendment. Maybe buffer systems, the buffer systems that are compatible with the soil. So instead of going for acids, using buffers in different. There is an article actually on that, using different levels of buffer systems and then going to the acid, so it goes from easy available, extractable to longer term bioavailability. Yeah, so that's
But it is important to help people understand the difference between total and available nutrients. So if you start with the distinction of, I know there's a difference, that's a big step in the right direction.
I'm new to biochar, this industry, but biochar has been around for a long time. Why are we now talking about developing standards when this has all been around for so long?
So it is a great question. And I think it has so much to do with global warming and carbon sequestration just kind of coming into our socioeconomic need. And, the thing is, I think historically, yes, we've received samples, and you make do, right? The number of times we get asked historically, going back 20 years or whatever, if we were to get biochar samples, we'd run them relatively the same as coal, and people would get their indication, and they weren't trying to get their carbon credit. Now that we have policies where there's financial implications, and they start citing standards, it becomes far more important for everybody to comply. And I think that's the reason it's now front and center, is because when policies come in place and the standards being referenced are ambiguous, it results in everybody's, oh my God, what are we really doing here? So I think it has a lot to do with the fact that we're now coming to age of needing to sequester carbon, and there's economic implications behind it.
Katie, would you tell us some more about your arid agroecosystem research? You were talking a little about sodic soils and just what type of applications there may be.
When I fell in love with biochar, I was listening to a talk about biochar's application in tropical places where the soils were leached, they were very acidic, there was no nutrients, no carbon, magnesium hanging around, and it seemed like the miracle material. And then I moved to New Mexico, and the soils there have pHs of 7 or 8. We have carbon, magnesium contents such that you can see a white crust forming on the soil after a little bit of rain. We have, there's a reason why New Mexico has the nation's only inland desalination plant research center, because a lot of our groundwaters are salty. And so most of the things I used to love about biochar, it's alkaline, it's got a liming capacity, it's got these nutrients. What used to be an advantage is now a liability. Because in the tropics and the wet areas, you have rain that's constantly washing those things away. In the desert, it'll rain for about 2 minutes. It'll dissolve the top layer of salts in the soil, and then it will evaporate. It never pushes the soil, or never puts the salt below the water. It never has enough water to push the salt down. And the pHs of the chars, 8, 9, 10 on a soil that's already got a pH of 7.9, 8.1, where you already have a manganese and an iron deficiency, and you're going to put it on. And so the most promising things we've seen about biochar is it improves erodibility, it gets better aggregate stability. And if you've seen the wind in New Mexico, well, in Arizona, if you've seen the wind, we get most of Arizona's topsoil, and Texas gets most of ours. And so anything to improve aggregate stability is great for wind erosion. And we've seen increases in soil water capacity. And if I can make a difference for a farmer of, 5 irrigations instead of 6, or the plants will survive 2 days longer between irrigations, that's a wonderful thing. But we have to be really, really careful about the salt and the pH. And so that's something I don't know if we understand. It's not this, like some things I think it's going to go really wrong and then the plants are fine. And other times, not so much. And so salt and pH were things I never used to worry about, at least not really, but I have to worry about now because we don't have that extra water to wash it away. Do you have a question? You had your hand up before.
One of the benefits I've heard mentioned repeatedly over the past couple of days is the soil water retention benefit of biochar. So I was curious, is there a standard for how to quantify that? And if so, is it like a soil water retention curve that you can do solely on the biochar itself versus doing field capacity and things like that in the field?
I'm glad you brought that up because I was going to bring it up. That's something that we really do not test for. There's no method currently in IBI for measuring biochar water retention capacity, much less that biochar as a mixture or a blend with different soil. So that's something definitely in the soil amendment application side that we need to look into and design easy methods that are accurately able to report the ability of that biochar to hold on to water, because that's major.
So in solid biofuels, we do. So basically, we were the project lead for this method. It was based on the idea of torrefaction and steam explosion. In solid biofuels, what we would do is we would take the product in pelletized form typically. And the idea here was if you submerge it in water, how much will it absorb and how much durability will be lost in the pellet. And so it's a water sorption method. That's what it's titled. It essentially includes taking the material, immersing it in water for 24 hours, pulling it out, and then measuring the difference in its original moisture content and the final moisture content, as well as what was the durability before and after. So there's a durability indicator, there's a moisture indicator. And the whole idea behind this is that when you thermally treat solid biofuels, you should no longer need to store them in a dome, store them in a shed. You can put them out in the yard. If they've been thermally treated, they should shed water. It's unlike a whitewood pellet would be destroyed to keep it outside. In this case, a method like this is available. It may not be perfectly suited and adapted for what you're describing, but it's a method that's already published, could provide an indication, and could be adapted.
EBC has a standard for that. This is a DIN standard as well that is, used for biochar. So there's a standard out there that can be adapted into IBI standards. So your question also is connected to the soil. So now the soil biochar interaction, that's very different. So you have intraporosity, that is within the biochar, the porosity, and interporosity, that is biochar and the soil particles. And in order to, the second analysis is what is really complicated. Now, which soil to pick, right? So because there's so many different types of soils and the interactions vary. Well, the first analysis, that is, if it's just for the biochar, it's easy. But that's not a correct representation of what's happening in the soil. But that's the best that can be done. Yeah.
What we do for our field studies is we use a particular soil, whatever the soil is at the field, and we take samples of the soil and then measure the water holding capacity of the soil using the standard soil methods, but it's always soil plus something. But we don't measure the holding capacity of the char. It's always the char in situ. And those are the numbers we have to use. Also with char, how do you get it to mix with water and not float? That gave me lots of headaches.
So basically, with the water sorption method, there's 2 layers of sieves, and when you put it in, if it is not dense enough to sink and it floats, then you have another sieve that sits on the top. So these would be nesting sieves, and then you fill the water level up above the second sieve.
We are producing biochar from biogas in Louisiana. There's a very high water holding capacity, and of course we measure it. We use a very simple method. 1 ounce of biogas, biochar, right? 4 ounces of water. We mix it, wait 5 minutes, put it on a 100 mesh, and measure the remaining water, and you know your water holding capacity. And we achieve like 3.5 times the weight of the biochar. So it's the simplest method that you can do in-house.
When we were first developing the water sorption method, there was a 7-minute test, and this was the interesting aspect is we had to, in the working group, we had to say, how's everybody doing it, and actually poll the industry and get everybody's feedback, and then deliberate over, is it 7 minutes right, or is it an hour right, or is it a 24-hour test, is it a 7-day test? I mean, these discussions go on a while, hence the reason it takes 3 years. But that's case in point. There could be applications where a quick test is more efficient and easy to give you field screening. We have some methods where we really just perform them in the laboratory as referee methods, whereas at the field sites, they have their own way of doing things. They're adapted, they're generally approved as part of the certification to be able to make modifications so they can make immediate decisions in the field. So this isn't uncommon to be able to adapt techniques in order to be able to manage your ongoing routine production. So, but that is why standardization is so important, because you have to then agree that those times and retentions are right. Otherwise, you have everybody doing something a little bit different, and you can't compare between anybody. It's just your own internal information.
Yeah, so I would say that, as long as it's consistent, that's the rough method will work, of course. But when you start looking at biochars, they have very high surface area and you have microporosity. Just like Katie was mentioning, chars don't like to get in water. You have to force it some mechanical way. And even when you force it, you think, well, they're wet, but they might not be wet. They're wet on the surface, but water molecules probably didn't travel all the way through those micropores. So sometimes methods require, as you mentioned, a little more time just to give water the chance of getting into all the micropores and having a more accurate way of measuring, or probably a higher, actually at the end you'll get a higher retention of water, a number, if you allow it to sit a little longer.
Thanks. My question's somewhat open-ended, but the certification requirements from EBC and IBI, we've seen them change over the years. Some things like germination inhibition, you've seen that drop off the list of requirements. My question is, as you're looking forward do you see the list of analyses that are required for certification dwindling? And if so, are there any tests that you would like to see also fall by the wayside? Thanks. Thank you.
Maybe I can answer. Yeah. Yes. There are this. It's more going towards do no harm route. So as long as it's not doing harm, such as heavy metals and toxicants, those will always stay. But probably maybe the calcium carbonate equivalent and those things which are like good to have, like way to use, maybe they will fall down. But I think it might move to, because there are different classes, and maybe they will be grouped into specific classes instead of having as common tests across those different classes you see in the EBC. And I have a point regarding germination inhibition assay, because we do it quite a lot. And we personally think that's a very important assay, because there are quite a lot of biochars. When you look at physical and chemical properties, it's all good. But when we look at the germination inhibition assay, something is, because we don't measure everything in the labs. We measure what we know. We cannot measure everything. So if you're looking for soil amendment, if you're looking for agricultural purposes, germination inhibition assay is important. Now, the method that's used for germination inhibition assay is it's a different question. Once again, it's a borrowed method, but it's taken out, but it needs to be done if it has to be used for, the biochar has to be used for agricultural purposes. So.
My guess is that we will not decrease the number of tests. Instead, we will probably categorize those tests to make the user be able to decide which categories they can analyze. Again, I wouldn't imagine somebody would exhaust all the tests unless they have to fully characterize that biochar. But the idea is to be able to have those analyses available, and then it's up to the user, producer, marketer, etc., to identify which set of characteristics are important for that one application.
So, I have no clue what IBI might do, but I know what tends to happen in standardization. You create a standard, and then more standards, and then yet more standards, and then you subdivide those into categories and create more standards for the subcategories, and it gets just bigger. So I don't think, I think in time, as the standards do develop, they'll become more robust, they'll become more specific and more dedicated to specific applications. So I think maybe instead of one analysis of all parameters is good for all, it'll become more like smaller suites of standard, but more pointed to the purpose.
I have one more $1 million question. There's two things currently important for biochar: carbon content and hydrogen to carbon ratio. Is there any tests that are upcoming that could be used on the fly to determine the hydrogen carbon ratio as we produce the product? Because retention, temperature, and catalysts determine that ratio. What would you recommend in the future to do to make sure that we can put out consistent product with the right ratios?
Well, on the fly, do you have anything on the fly? I don't know that I have any ideas for an on the fly H to C. Do you?
Remember what I said about biochar color? Yeah. What should it be? Close enough. Because if it was dark brown, chances are your H to C ratio is too high.
Yeah.
And
Yeah. I was going to say it depends, but just to be funny. But you're right. I don't know of any other way of measuring it faster. But if your feedstock is very consistent and your process is very consistent in terms of pyrolysis temperature, residence time, yeah. But you can produce curves. You really can. I've done that when I've played around with pyrolysis temperatures, residence times, the same feedstocks, and it's pretty accurate. And at one point in time, you know, if these are my conditions, if this is my feedstock, that's my H to C ratio. You know it, but of course that's not enough for you to get your carbon credits. You have to have a certified. Really? Well, I guess this is one of the issues that has to be addressed. It's part of the standards and certification. It's to make sure we get accurate results from laboratories, and we don't know if that's the case right now. Yes. We are close to wrapping up. We have about a couple of minutes left for a couple of questions. Questions, comments, suggestions?
A quick comment on the H to C. So on that question, the way that we go about doing it on like trying to get consistent results for that ratio is it's heavily on the pre-processing. So we chip it up, and then it goes through like a drying process like on its own until it gets to a certain to whatever our certain like desired, I guess, dryness is. And then once it gets that, like that's where it gets standardized. And then the rest of it just follows the pyrolysis and the rest of the process. So that's how we go about trying to standardize it, and we've had like decent results. But it is heavily like how because a lot of it is like you just put the feedstock in. There, like people don't really want to chip it, but if that's the only way, like if somebody knows of a better way, like who knows? That's the way that we're doing it.
See, Mom, I'm getting my steps in.
So just two comments. First, on the H to C ratio, a lot of it comes down to the equipment that's being used as well. A lot of HCN analyzers utilize very small volume samples. So sampling procedures and standardization on that, making sure you have a robust sampling milling protocol, that you're getting those down into a fine powder that can be analyzed. When you're only pulling 100, 250 microgram sample for analysis, there's an incredible degree of variability, especially when you're talking about a chip biochar. You could grab the inside of a material that is 80% pyrolyzed with a little bit of torrefied material internally. If you get the inside of it, you'll see an H to C ratio of 0.9, where the rest of your material's at 0.4. And so that, I greatly appreciate the speaking to standardization and making sure that the entire process of sampling and sample preparation is properly standardized. Second comment is regarding the germination. I'm very glad to hear that there's a push to make those standards or make that testing applicable again. I've worked with a lot of different biochars, and I've seen some that have me very concerned about going into the field and some that are phenomenal. So it's an incredibly important test to take into consideration, because if you are going into a field, making sure that you do no harm at absolute bare minimum, because the goal is to improve the fields, not cause issues. So thank you very much. It was a very informative session.
Yeah, going back to that ultimate analysis where you can calculate the CHNOS and calculate the molar ratios to get to that value. The quantities of sample are minuscule. So what I would say is we would have to start with a large sample size, grind it to the level that has to be ground, dry it, and probably do at least 5 reps on that one, at least. And just, yeah, it's hard, yes. And that's probably why you got different results.
Another comment to the hydrogen. maybe Chris could speak more to this, but there's different ways to categorize the hydrogen. This is why standardization is important, because in the methodology, different methods do a different way as incorporating the moisture content into the original hydrogen number, which can over-calculate or overstate the hydrogen to carbon ratio.
Yeah, and another difference is calibration. We were actually discussing it before. So normally we calibrate at the start and then run several samples. If that is done, it's a problem. So there should be calibration in between the samples. So that gives rather accurate data. And yes, the particle size is really, really important. Grind it to like 0.2 millimeters or so, and that's when you get good sample size. Yep. No, the lab should be able to grind it. Yeah. So if they're doing it right, they should grind it to the particle size. Yeah.
I'd speak to that. So in the IBI standard, the method says use an HC analyzer.
And they say less than 3 millimeters.
Right. And that's all it says. It doesn't say which method to use. It doesn't say which industry's method to use. And as David was implying, some of those methods actually use the hydrogen of the water in the calculation of the hydrogen. So you'll get a completely different value if you use E872 than you would with an ISO method or any other method. So you got to be very careful on which method you pick. And you know, there's so many issues that go into this, and that's why the standardization, again, I just repeat it, it's extremely important. Preparation, sample size, all of it.
Thank you all for your very pertinent questions, and thanks for attending. And we're wrapping it up. It's time. And if you have additional questions, you can always email us. Just let's see. You can find us. You can go to the beginning. You can find our names here. And if you have any more questions, comments, please feel free to email us. We want to get this process started in terms of starting to develop some standard methods for biochar analysis. And it's probably going to be a long haul, but it's a worthwhile one. All right. Guess I have anything else? All right. Thank you.
Biochar.org appreciates the support of our sponsors, exhibitors, presenters, and attendees. We look forward to seeing you at our next conference in September 2025.